Welcome to our 3D printed optical force sensor project. Our project is being controlled by an Arduino Nano AV board. Here we have videos and images of our progress circuits that is testing out the functions of our components and their performance before building the initial project.
We now move into the 3D printing process where we used a Prusa IMK3 to print all of the parts of our project. Shown here is our first working model with our 3D printed components incorporated.
Here we're using a multimeter to measure the voltage drop across a phototransistor when it's detecting light and when the light is blocked.
This clip shows the inside of the completed device. Now, the demo.
This footage will explain how the calibration button functions. By placing an object on the sensor, we wait for it to read the force applied and press the calibration button to set that weight as 0. When removing the object, it will read the previous reading prior to pressing that button. It would have been a negative value, but we have used absolute value in our code to avoid unrealistic readings.
This video shows the operation of our device with known weights. The smaller object is of 200 grams and the larger is of 500. The output should read 1.96 and 4.9 respectively. We see that there is minimal variation when the weights are moved to a different sensor location. Once we confirmed that the sensors were accurately reading the force values, we knew that our device would perform optimally. The sensitivity of the phototransistors suggests that with proper calibration, this sensing technology could be used to develop robots with human-like touch.